My name is Greg Meyer. With me is Brian Kelly, and we're from a healthcare software company called Cerner out of Kansas City. And this session is really going to be about quantifying your return on investment on your platforms and your processes. So a lot of us here are this week to learn about Spring, the latest and greatest stuff, as well as Kubernetes, Cloud Foundry. And what we're going to hear a lot about, or what you probably already heard about a lot about, is value. And most of us know that value can have a lot of different meanings in a lot of different contexts. So if you think about in terms of development, we hear value in terms of go fast. We heard that a lot in the keynote this morning. We've heard a lot of different things in terms of CI/CD, where we can get automated integration, automated deployments out to our production environments, and then value in DevOps. Operators love it. We heard that a lot this morning too. But when we think about value, a lot of these are kind of abstract concepts. So when you stand in front of your CEO and your CFOs and your CIOs, and they're wanting to know, well, what value am I really going to get out of this? And you don't want to come up to them and say, well, it's awesome, platform, operators love this. They're going to want some more hardcore numbers. So that's what we're going to take the next 20-some minutes here, is we're going to look at some different processes that we've used internally in Cerner. We're going to rip out some real-life use cases that we've come across in the past X number of months, and we're going to do some real hard numbers against that. So let me kind of take you back a couple years here of how we got started on this. About 2 years ago, our executive leadership came up to us and gave us an opportunity to create pretty much any type, or what we would thought would be our Nirvana platform and architecture. So number one, if anybody ever gets that type of opportunity, that's a total dream to go get that. So Brian and I, we spent a little time, we developed what we thought our Nirvana system would be, and we came up with, we're going to go do this on Cloud Foundry, specifically PCF. So we put together our stories, we evangelized, we went up to our exec leadership, said this is what we want to go do. Fortunately, we did get a proof of concept, so we got a budget. Honestly, it was actually some credits from AWS, some trial software from Pivotal they want to sell to us, so that's all great. And over the next X number of months, we got to build out what we thought was our little paradise. So we got our proof of concept going, we built this, we had a lot of apps up there. Eventually we got the contract signed. And I think in January of this year, we started our dojos. And I think as of Friday of last week, we have 7 production systems up and running on this. So it's all great, we love it. We actually want to go expand it. There's a lot more value, in using that term value, that we see other teams could get out of this. So now we've got to go back to our senior exec leadership and testify to them and say, hey, we want to expand this. So what type of story are we going to tell them? We're going to say, we can go fast, it's awesome, operators love this. I'm like, no. These guys are going to say, no, show me the money. What are we really getting out of this? What's our return on investment on this? So we've had to go back and try to figure out what are those numbers that we can present back to our leadership to get approval to go forward on this. So there's a couple tools that we've utilized. We're going to look at this from kind of 2 different aspects. One, I'm going to walk through some of the things that we've done in the development side and the application side to get those numbers. And then Brian, I think he gets the real interesting part of this with the fireworks of showing some of the platform and infrastructure sides. So there's some wow numbers in there. The first use case I'll jump into, we were using value stream mapping to go do that, and I didn't intend this session to be a long session on value stream mapping, but to kind of oversimplify it grossly, is value streams are kind of taking a process from when you start to the end when you're trying to crank out, or when you finally start cranking out value to folks. And then value stream mapping is doing the analysis on that to try to figure out where your resources and your time is going and trying to flush out those inefficiencies, and then in the end trying to plug those in and get some type of metrics, typically like a dollar amount. So we'll go through about 4 use cases here. I hope these are kind of relate to some of you that you've run into, but our first one here was we lost a development database. Not the biggest tragedy in the world. It's not production, but it still is development, so there's an impact on that. And to give some context here, you're going to see legacy on the left side, PCF on the right side. So our legacy system that we're previously running, it was PET VMs. We're generally running like 2 of them in an HA mode, whereas PCF, we all know what you can get out of Cloud Foundry. So we did the analysis on this using value streams mapping, and this is kind of what it went to. And actually, the interesting part of this as well is that we're actually supporting both legacy and PCF at the same time because we weren't live on it until not too long ago. And we actually ran into this exact scenario happened in legacy and PCF within a couple days of each other, so it was kind of cool to get to do this analysis. So if we look at the legacy side, we have a centralized infrastructure team. So we had to go log a JIRA. It takes about 5 or 10 minutes to go make that happen. They picked it up after about 2 days, so that's our lead time. You know, it wasn't real high priority. They had production things to go do. So they went through their process of analysis, tried to go find backups of the system, and turns out, oops, they don't do backups for development systems. So they had to go rebuild a VM from scratch, the database, install the software, and after 7 days and about 2 or 3 resources, they said, here's your database. Oh, by the way, there's no data in it, but you got your database back. On the same side, when we went to PCF, Brian actually runs that for us. We're using a GitOps type style of operation. So same thing, I logged something into Git issues. Brian's really efficient, so within about 1 or 2 hours, he picked it up, was able to go find the volumes because we get backups automatically as part of our database services. And within about 2 or 3 hours, I had a complete database backup. So now I do my analysis on this. I go from 7 days, no data, 2 or 3 resources compared to 3 or 4 hours, and I've got everything. And actually, if I was okay with no data, I actually could have done this self-service myself and just renamed the existing database service and then just done a reprovision. It would have taken all of 5 minutes. So going back to value stream mappings, then you go plug these into formulas. I'm not going to bore you with that. There's actually a really good session tomorrow at 5 on value stream mapping. So if you want to get into the gory details of that, that's a great one to go to. And so we can plug these numbers into a formula or a template, and we can come back and we can go get a dollar amount or some type of other metric assigned to that. Next use case, we actually had a cell loss, a Diego cell loss in our production system about 5 or 6 weeks back. No big deal, it recovered itself quickly, but we were interested what would end up happening if this happened to our legacy system. Yeah, we're running 2 nodes, so we want to bring one of those back up. Fortunately, we're not going to lose anything because we are in HA mode, but we still went back and did the interviews with all of our infrastructure teams to figure out what would end up happening. So we went through the process. You know, they tell us BMC Patrol says node out. So they do a page out, which they're telling us it'll take about 10 minutes to get an infrastructure team on the phone. They'll do all of their work, failure analysis, build the VMs, and then they'll go hand that off to an application support specialist who's on my team, and then he'll go do the automated reinstalls. As we went through all the lead times and action times, they said that it would take about 3 hours and about 4 resources. I talked to my support specialist. He actually said, that's your best case scenario you're ever going to see. It's more like 6 to 8 hours to just bring that up. Conversely, when this happened on PCF, Bosch detected it. Within 5 to 15 minutes, depends on your IaaS, we had those services back up because it just autonomously rescales and redeploys and balances out those services to other nodes or cells. We had 9 of them, so again, no big deal. So as we look at the variance here, 6 to 8 hours versus 5 minutes, all these resources, 3 to 4 resources versus 0. And I love the 0, the autonomous, because it really takes all those variables out. Before we plugged this in, I was curious, well, what happens if we lose both nodes? Now I'm talking about doubling that time, 6 to 8 hours just to bring one up. Now we're talking about SLA penalties in there. 6 to 8 hours is not acceptable in our SLA contracts. Versus PCF, I can't remember if Bosch will do that in parallel or not, but we can at least bring some service up, if not all the services up, back in 5 minutes. So now we plug that in, and we get SLA penalties plus resources plus time versus the other, and we get a nice, interesting number. A couple other ones here really quick. We wanted to build a blue-green environment. I know the folks were talking about blue-green in the StubHub conversation earlier. Effectively, what our blue-green stack looked like in Legacy is they just re-implemented and duplicated the stack and then did some magic VIP networking, to flip between the two. It took them, and I'm serious about this, 2.5 years to build that second stack and to get all the networking together. I'm still going through the analysis. I'm not done with it, but I'm serious. It was 2.5 years. When we did this in PCF, we kicked off the dojo in January, took about a week of network config, a week of building out the platforms, and then we had already been, my team on the app side had already been doing everything on a PCF and OpenStack, so all of our Concourse pipelines were ready to go. We'd been doing it. We just have to change out some of the param configs. That's the great thing about Cloud Foundry and PCF. It doesn't matter what IaaS on it. It's the exact same process. And we're up in literally 11 days, full dev to prod. So I don't have numbers on that to plug in a formula, but again, 2.5 years versus 11 days, that should be a killer number to present back to exec leadership. And then lastly, we did some analysis on our capacity utilization. This translates a lot more easily, I think, into dollars than anything else, so we can present this quickly. What we found out is that we did cut back our CPU utilization and memory utilization. We did need a little more disk storage just because we didn't allocate enough in our current production, but disk is cheap. But what's most interesting about this one, and I don't expect you to read these numbers, is that we found out we just put way too much capacity on our production systems. And a lot of that was the fact that the way that we did the stack, 50% of it's just sitting there idle all the time because we're flipping back and forth. But at the same time, our development systems were way, way too small. So those things needed a little more love given to them. So in the end, moving to PCF, not only did we reduce the amount of memory and CPUs that we needed in nodes, we actually leveled off things. So we got a much better capacity utilization and production, and dev got a lot more love in terms of the capacity. So, and not only that, now we have a pretty consistent looking environment between all of our environments. So I don't know how your dev environments look versus prod. Ours never, ever were even close to the same. We've got a nice level consistency. And then lastly, we did cut the number of nodes that we were using in half. I mean, these are virtual machines. There's a lot of fuzzy logic in there, but when it comes with nodes, there's a lot of other things that come with that open up another slew of problems in terms of management, doing patching, CVEs, OS upgrades. So there's a lot of operational pieces to that. And I think that's a pretty good segue now to jump over to Brian and talk about ops.
Sure. So first of all, I'd like to thank you for not going to Josh Long's talk. He's at 5 right now, so I appreciate that. That's where I would be right now, so awesome for coming. So Anzi actually provided some pretty interesting metric today that was a problem that we felt, which was they release a security patch every 6 days. So we have to take an update every 6 days. And all 3 foundations that we have every 6 days. And it's a overwhelming feeling as an operator. And I'm not going to use the operator term. Just as engineers in general, it's overwhelming to think that we got to take an update every 6 days. And I'm not saying that it's forced upon us, but they're releasing it for a reason. So we started doing an assessment on how healthy is our platform pipelines. How often were they running? And we found that we had automation, but we weren't running it. We were running it when maybe we would see an update that we wanted would come out, and that made me unhappy. They're doing all this hard work, they're releasing all these security updates or these minor enhancements, and I was not doing a good enough job of getting it into our production systems in an expedited fashion. So we decided to put together a checklist to ask ourselves, and application teams could do the same thing, is how often is your platform or your application taking updates? How many new features are you delivering through your pipelines? How many security vulnerabilities are you remediating? And how often are you backing up your ops manager or your environment in general? And we found there was a lot of gaps and things that we were not backing up, and pipelines can be there to help with that. So what my goal was, okay, can we assess that? Can we make a determination on how well we're doing that? And I found out I had no metrics either. So I didn't know, I couldn't even grade myself. I had no metrics, I had no idea. I tried to go into Ops Manager and look at the change log, and It was just a log. It didn't provide me a metric that I was looking for. So I said, well, we need to solve this problem. So how many and when? So I want to know, how many stem cell upgrades have we taken and when did we take them? How many tile upgrades did we take and when did we take them? The same with when was a new tile introduced? So there's new things coming out all the time. You know, there was a new relic tile that came out. There's fire hose and nozzles and third-party capabilities coming out all the time, as well as things from Pivotal. When were those introduced? How long did it take us to get it all the way to prod? And how many and when was the security vulnerability remediated? And one of the scariest ones was very recently, there was a L1 fault vulnerability that was Spectre related that Pivotal released a stem cell for, and we were able to get it into our sandbox environment on a Monday or Tuesday, and we were in prod by Friday. And now we have a metric to monitor that. We know when that was taken because we know the stem cell version that it was in, and we can now, and I'll show how we're doing this, we have a metric that we're using to know when was it taken, who took it, and on what date. And so we developed a process that we're now calling our GitOps process. And it's all based upon Git. So we don't want the human to be the thing that's blunting the capability. We want the bots being able to do all the work. And so what our goal was can we get the bot to go and all the human has to do is say, yes, you can go do this. That's what we wanted our pipelines to do. So I said, okay, here is our best practices. We're going to treat everything as code. Because engineers like code, they like looking at code. They don't necessarily like looking at a release notes or an email. They want to look at code. So let's get in front of them the release notes for the change that they're taking. Let's get in front of them the version of what it is that they're taking and put it in with the code, and Git actually provided all of this in one view using pull requests. Let's reduce the risk by making changes as a pair. Let's make sure we have another engineer with you going through the release notes and evaluating all the features that are coming so we feel comfortable about the changes that are coming in. So the humans all they're doing is assessing the risk. They're not going to make a decision on anything other than that. So basically, when are they going to choose to merge the request in? Changes are always going to now go through pull requests in Git. So what that means is when a version of a tile is going to change, we're not going into the ops manager and importing the tile and applying changes, because why do that? There's humans that need to do better things with their time. Let's let the bot do that. Let's let a pipeline do that. Pick your choice of technology. We happen to use Concourse, but you can use probably a lot of different technologies to do that. But treat it as code. Make that decision something that you do as code. And then we started doing some additional things to gather metrics. We started labeling the pull requests in Git. Just a Git feature, put a label on it. You can do a lot of metric calculations using labels. Let the bots put the labels on the issues. Let the bots make the changes to the files for you when they create the pull request for you. And also use selective deployments in Ops Manager so that you only know that specific product is changing when you're applying the change. Not all the world is having changes applied and errands are being run. Let's make sure that when there's a RabbitMQ upgrade, only the RabbitMQ upgrade deployments are changing, and only those stem cells are changing at that time. And then we've come up with a domain-driven promotion process where we can choose to take certain tiles at different frequencies. So if it's Elastic Runtime or Pivotal Application Services, or it's the Ops Manager, if it's anything that's 100% uptime, we take those changes pretty much every Friday. So whatever we were able to take in during that week, we release it to production on that Friday. And that allows us to stay in the same cadence release as what Pivotal's doing with their releases to PivNet. And you're probably asking yourself, well, how do you know the changes that are coming in? Because most of us today get email digests. And so what we've done is, this is an example of a pull request that comes in. A bot created this, actually. So the pull request comes in and harvests off of PivNet the release notes so that the human can go read those to make a decision. It tells you what stem cell it came in, and then we put some labels on it. So the foundation that it's going to go to, the tile that it's going to update, the fact that it's a stem cell upgrade and there's a tile upgrade. These can be arbitrary things. It's all driven by our domain, but the goal was so that we had some sort of annotations on the pull request so we knew what was changing, so that we can go in and run reports. Don't like doing reports, but it's one of those things where you got to do it, because every time my executive or Paul, my platform architect, would come to me and ask, well, how many stem cell upgrades have you taken? I'd go, I don't know. How many have you released? And so now I can tell them that since May 23rd, for instance, we've taken 70 stem cell upgrades to production. Right? And anybody can now go run the report. I don't have to go run the report and tell them. It's all self-service. So if they want to know how many platform or PaaS upgrades have we taken, they can go in and say, click on the tile, platform or pivotal application services, pick on the foundation prod, and they'll tell you. Don't ask me anymore. Self-service, autonomy. I don't want to answer these questions anymore. I was answering it almost every single day. So what it will typically look like is something that everybody's familiar with. This is the diff. This is the file. Really simple. It's not rocket science. This is the two versions that changed. The tile version changed and the stem cell version changed. So when you clicked on that, I think I may have cut it off in the screenshot, but down below there's a merge button. You're familiar with Git. You click the merge button, that's the only action you have to take. And then the pipeline would trigger because a state changed in the Git repo. And then it would download off of PivNet the version, and then it would push that version into the environment that was targeted from the label. So this works great if you know a static version. So one of the other changes that we made is, this screenshot's probably a little harder to read, but in Sandbox it's a glob pattern. So it's continuously polling PivNet every 30 minutes to see if there's a new version that matches this glob pattern. Our Sandbox environment is our most secure environment in our entire pipeline because it says it's updating as if it's a browser on your desktop. Because it is literally taking the updates off of PivNet whenever they come out, selectively deploying the stem cell or the regex pattern for the tile, and then rolling that through that environment completely autonomously. There's no human interaction in Sandbox.
It's interesting as he says that a lot of times that code actually rolls into our Sandbox environments before he even gets notified that it's out there.
Great, yes. So PivNet sends a digest at the end of the day, typically. We've already had it applied in Sandbox when I get the email. And that's a really cool feeling because you can then review the release notes against something that's running instead of having to review the release notes and then decide to take the update. So you can go in and play with it and stuff like that, which is a really cool feature of the pipeline and just a natural byproduct. This is an example of what the pipeline looks like today. It's very different from what PCF Pipelines does. We're working very closely with the automation team. There's some features in this that don't exist outside of probably some pivotal pipelines. One of those features being locks. So one of the downsides of Ops Manager is it can only be applying changes at one time. But we did find out that it can take uploads as often as you would like. So the upload is broken away from the apply changes. So we've had scenarios where many tiles have to take one stem cell upgrade over across multiples because they're all on the same stem cell version. So what will happen is the upload will trigger on all these different tiles in parallel. And then they'll acquire a lock to apply the change. And whoever gets in first wins is kind of the philosophy we have. So if you get the applied changes locked, now you own the ability to make a change to the system. And so what's really cool about that in Sandbox is it allows it to be autonomous. It allows it to be self-driving. It also takes a backup of your ops manager every time that the changes are applied, which is really comforting because you're wanting to move quickly without having a lot of risk. So you have those backups in case you lose your ops manager VM or something disastrous happens. And then one of the features that we've added is at the end is the create pull request to the next foundation. We call it in a chain. We think of it as a linked list because we're engineers and we're goofy like that. So basically what happens is in that job is it takes the version of the tile in the stem cell that existed and past deploying to, say, Sandbox or Dev, and creates a pull request to the next environment and foundation that we'd want it to go to. Then I get an email in Git, which is in my dashboard and my notification dashboard that everything else is that I have. And what we're calling this now is Git Ops. So we shifted all the responsibility left to engineering. Engineering's now making the choice on when they apply those changes to environments. It's in a tool that they're already familiar with, and it's also gathering metrics and value for us autonomously, and I don't have to do it anymore. So that's why I wanted to share, because I like capturing the metrics, but I don't necessarily like having a spreadsheet that I'm putting all of that information in. And so that's kind of the gist of what we're doing. Some just simple facts. We're able to keep up now with Pivotal's rapid iterations. It's cool to hear, but it's really daunting as somebody who has to consume those updates. Because now we're able, like I said, we've taken over 70 different stem cell upgrades. We're able to move very, very quickly with very, very little risk. We're able to review the changes and tooling that we're familiar with, and we have traceability. And in our field of play, being an FDA-regulated software company, we have to show really interesting tracing. I don't know why they're so interested in it, but so we're treating it as a product, so it's going through all of the change management processes that we do with any other product. I think tomorrow there's a talk about value streaming that I think you wanted to plug.
Yep. Cool. I'd mentioned that earlier. If you want to learn a lot more about value streams, that'd be a great one to go to. I was going to make one other mention on the shift left, and you can see this as a downside or an upside. When we ended up first going live, specifically my team, we do like weekly meetings with our operations team. When we went live on this, that was a very awkward meeting, just in terms of there was a lot of time where we just heard the lights buzzing, and that was it. Yeah. There wasn't a lot to talk about anymore. Everything became so autonomous. There just wasn't a lot for them to do, which I'm assure you, your operations folks can find lots of other things to do, but having to worry about these systems just wasn't anything they had to worry about anymore.
And the other added benefit of being able to do it at 9:30 in the morning on a Friday instead of at 9:30 at night or 9:30 on a weekend is always such a nice feeling as well.
Yep, we actually, my team just pushed stuff into production at 10 o'clock this morning, all in uptime, right in the middle of all the business hours.
Yeah. Why not?
No big deal.
Yep. So we'll be around to answer any questions if you have any, or we can take them.
I think we've got about 3 minutes here, so we can, or 4 minutes. Anybody got any questions? We can. Yeah, go ahead.
So what are the operations guys doing now?
I'll answer that question.
Okay, so the question was, what are our operations folks doing now?
So our goal is to help them become site reliability engineers and plug them more into the application development lifecycle so that they can help.
Teams.
Yeah, and so they can become more cross-functional so that they can help us with what metrics should we be looking at in more of our APM tooling, what alerts and what alarming should be in those applications, because I will say this, even with the move to Cloud Foundry, it's really a domain-specific thing, how you're going to monitor your solutions and what thresholds you should have. And we're wanting them to be more plugged into that because we still value their relationships that they have with our clients. And so plugging them into knowing when there's an issue and when it was caused and what the remediation will be is still their job.
I mean, and
we're not taking that away.
We still touch a lot of other pieces that are not part of Cloud Foundry, so those folks are also really good. As he mentioned, they've got the contacts out there. Yeah. They're very, very good at being able to track folks down. So having those relationships with the other teams is absolutely critical. Yeah. Yes, sir.
Have you had the need to institute error budgets or to monitor or to police bad deployments?
Okay, so the question was, have we had to introduce anything basically to watch for bad deployments and add that and budget for that and add that into our processes? I think it's effectively what you had.
Yes. So we are running a surplus currently, which is good because we've not had a lot of errors. But yes, we do have the ability to roll back changes in production for applications. The reason why we have 3 foundations that we take platform updates to. I think of it as a carpentry type of philosophy. We want to measure twice and cut once. So we really want to ensure that any changes that we make in Sandbox, we also do the same changes in Dev, and then we don't do them in prod until we've seen stability. So we've had a lot of success with that. So the error budget on the platform side is, we haven't even had to tap it. Mostly because most of all the updates that we do make are in uptime. We do have a little bit longer budget for data services like MySQL and Redis because they are downtime changes. But there again, we schedule those. And if we were to have an issue with that, the goal would be to do it on a case-by-case basis because each solution has an on-demand service instance, and we haven't had issues as we started to break up the monoliths. We distributed a lot of the data services risk, And that actually, I don't know if you would think this, I think that actually has improved our reliability.
Yeah, it has quite a bit. And to add one of that on from the app side of it, part of our policy and process that we have because we're FDA regulated and our ISO is we do have to have a rollback policy, and we prefer to roll forward, and we're going to get there.
Yeah.
But we do have inside of our Concourse pipelines the same thing he did. We do everything a lot more agile on a service by service basis because of the blue-green deployments we're at now. We do have every pipeline service has a roll backup. In Concourse, every single one of them right now is still gray.
So the goal would be to avoid tapping into the air budget and roll back if we detect a failure, and so we have smoke tests to help with that as well.
I think we've hit the end of our time here, so we'll stick around here or go outside if anybody's got any more questions. But thanks everybody for your time.
Thank you.